Hi, and welcome back to the wonderful world of the scientific hypothesis. My name is Brad Alger. In earlier videos, I've defined the reproducibility crisis and shown how the material complexities of nature can undermine attempts to obtain reproducible data. In this video, I want to look at factors that I'll call intangibles because they don't deal with the materials that scientists use or study. Rather, they involve the behavior of the scientists themselves. They reflect the fact that scientists are fallible human beings, they occasionally make errors in thinking, and a few can behave badly, even dishonorably, with respect to their subject matter and their colleagues. This is scientific misconduct, and it ranges in seriousness from minor transgressions to outright fraud. These factors are sometimes thought to bear the major responsibility for the reproducibility crisis, but their actual influence is hard to gauge. Nevertheless, they're obviously wrong and they should be stopped. And at the end of this video, I'll make some suggestions for how things might be corrected. How does scientists' own behavior contribute to the reproducibility crisis? We'll touch on fraud or misconduct, as well as the ways in which the reward system of science inadvertently incentivizes such behavior. I'll mention briefly some cognitive issues that we've heard about before, and finish up with some possible correctives to these problems. A sign that something is wrong is that journals have formally retracted published papers, that is, papers later found to be flawed, at an increasing rate in the years 2000 to 2012. They've gone up tenfold. The current rate of retracted papers is 4 out of 10,000, or 0.04%. There are many causes for retraction, including accidental errors later found by authors themselves, plagiarism, which is copying from others or from yourself, as well as different forms of data manipulation, including fairly mild ones from data beautification, that is omitting an occasional outlying point to make the overall graph look better, to data falsification, which represents more serious data manipulation, and finally data fabrication, which is making it up entirely. In a major study of over 10,000 retracted papers published in Science in 2018, the authors concluded that the most important factor in an increasing number of retractions was better editorial oversight, not a crisis in science. Nevertheless, there were problems. Known cases of fraud accounted for 1.2 to 2.4 out of every 10,000 articles published, and yet undetected fraud cases might have been as much as 100 times greater. The impact of fraudulent papers on reproducibility is unknown, as is the number of misconduct or questionable research practices, which may also affect reproducibility. Nevertheless, science is all about finding the truth. Why do some scientists lie? Both the review article and this book go into some detail into the most flagrant cases of fraud, of serial fraud committed by a relatively small number of scientists. Here are the top 5. Fujii, thus far, has had 183 of his papers retracted. Joachim Bolt has 153, and so on. These are clearly extreme cases of falsification of data. The occurrence of repeat fraud seemed to be quite alarming. It was found that 1.7% of all of the authors in the retraction database, 500 out of a total of 30,000, accounted for 25% of the 10,500 retractions that were analyzed. What is very strange is that it seems that serial fraudsters like this should know that they'll be found out. An example would be Jan Henrik Schurn, who was responsible for 33 retractions, was a theoretical physicist, and 17 of his papers were in the most prominent journals in Science and Nature. Surely, you would think, a person as brilliant must have guessed that he would be found out. Does his behavior represent rational actions at all? This raises the question of whether or not committing scientific fraud is ever a rational act. Will it go undetected? Will it be rewarded? Will the rewards outweigh the risks of detection? Regrettably, we'd have to say that due to certain intangible factors, some of which are encompassed in the idea of the culture of science and its flawed reward system, we'd have to conclude that the answer may be yes, it may in some sense be rational. The reward system includes access to jobs, grants, and professional recognition. It is often thought that publication prominence tops research validity of your findings, that quantity beats quality. Often the researchers who publish more papers are valued more highly than those who publish fewer papers. And finally, it often seems to be the case that the amount of grant money you have is too influential in your peer evaluations. Changing the culture of science might seem as though it would be fairly straightforward. There are cures that we can imagine. We should change the cultural value and methods of assessing. We should recognize the quality of research results and not their quantity or the flashiness of their publication venue. We should improve the quality of reviews and train reviewers and editors to make better judgments. We should reward publications of significant negative findings. One of the challenges to this sort of change is that it is easy to say, but it may be very hard to put into practice. In principle, there is a better way to do a lot of these things. We could try rewarding substantive contributions instead of surrogates for substance, such as the Star Journal publications and so on. Substantive contributions to knowledge would be those that are true as far as we know. These are well-tested hypotheses, and they've achieved a measure of community consensus about the importance of the results. There are indeed some rewards in science for this kind of substance, such as the Nobel Prize, the Lasker Awards, and so on. The challenges here are that there are only a few scientists that can get the big awards. The question would be how to decide if a contribution is significant, who would decide, and on what basis, and how to acknowledge the ordinary significant contributions to knowledge that most scientists make. Finally, a problem is that it takes time to judge real significance in a contribution. And this may penalize younger scientists. If it takes 3 or 4 years to recognize the worth of a paper, then they would be at a disadvantage when it comes to getting jobs since their work would not have been validated yet. Another class of the intangible factors that result in irreproducibility would be some of the cognitive issues that I've already alluded to and won't go into in much detail here. But the examples would be biases such as confirmation and publication bias, as well as cognitive illusions, which you remember are cases in which you fool yourself. There are other reasoning errors that scientists make in trying to assess their own results, and this has been pointed out in a recent editorial. Clearly, if erroneous thinking forms the conclusions of a paper, then the paper's conclusions will be irreproducible by other scientists. Cures for this kind of thing would include better education, that is, greater awareness of biases, as well as explicit training in critical thinking skills that most scientists don't get. We could also encourage better practices such as explicit hypothesis testing, which may lead many people to better reasoning and structure of their experimental projects. And finally, we would improve scientists' training in statistical analysis, which is another source of problems in reproducibility. The challenges here are to recognize the problems to begin with and to broaden scientific education to encompass things which are presently uncovered by it. To summarize a lot of what we've said about the reproducibility crisis, there are many contributing factors. Some irreproducibility is inevitable. Nature, after all, is very complex, but how to assess this and how much irreproducibility should we tolerate? Major outright fraud seems to be quite rare, and the question that I've raised today is whether or not it is in fact fully rational. If not, how would we remove irrational scientists from the profession? Minor fraud or questionable research practices is surely much more common, but their impact on science is hard to gauge. It could be significant, but we don't really know. The reward system of science bears much of the blame for the incentives that lead people to engage in scientific misconduct or other bad behavior. Reviewers of articles and grants, as well as editors of journals, are the gatekeepers of what gets into the scientific record, and they must bear a major portion of the burden for setting things right. Finally, new science policies might correct some of the problems, but even they will be difficult to design and enforce. Thanks for watching. Remember to give it a thumbs up if you like it and subscribe to hear more. See you next time.